Hi, this is Kenny Lee, and let's talk about some basic Newton's second law problems. Now, with Newton's second law, we have basically the equation itself. That's Newton's second law, F net equals ma. But usually in this unit, there's a couple other equations that we use quite often. And one is this one, where net force is also the summation of all the forces. Now that Greek letter sigma just simply means we're going to add things up. So as a nice little shorthand, we can just do F net is equal to all the forces going one way minus all the forces going the other direction. And it doesn't matter if this is up, down, left, right. It doesn't make any difference. All forces going the same direction, add. All forces going opposite directions, subtract. Okay? And then we also have the equation for weight of an object, where weight, Fg, I use that for weight, is equal to mass times gravity, and gravity on the Earth is 9.8 meters per second squared. Let's look at these two. Let's start off with the green side. And on it, we've got a 15 kilogram cart is being accelerated at 7 meters per second squared, and I want to find the net force on the cart. It doesn't mention anything about friction or anything holding the car back. And so for this, we're just going to use F net equals ma, where the mass is 15 kilograms. The acceleration was 7 meters per second squared, and we're looking for the net force. Now, if it doesn't mention anything about any extra forces, then the net force is the force being applied to that object. And so we just have to fill in the numbers. Mass is 15, acceleration is 7. And so if we take 15 times 7, we get 105. So that means that force being applied to it is 105 newtons to get that cart to accelerate at that rate. Now let's look over here at this blue one. A 6 kilogram box is being pushed by a force of 27 newtons to the right. If there's no friction between the box and the table, what's the box's acceleration? So sometimes it's better to make a picture of the situation. And so there's the picture. We got a force pushing the box to the right. Box is 6 kilograms, and there's no friction, so we don't have to worry about anything else. So we'll still use this, F net equals ma. And since that's the only force present, it's automatically the net force. So 27 equals 6a. Divide both sides by 6, and we get 4.5. So we have 4.5 meters per second squared is the acceleration for that one. And we can do the same process if we need to find the mass instead of the acceleration. We would still divide both sides by 6 right there. So let's talk about weight. Weight is the force due to gravity on an object. And we can actually calculate that by using the equation that we got earlier with Fg, weight, is equal to mass times gravity. Now on the Earth, G is 9.8. And for most of our problems, we're going to say we're on the Earth. But if you're on the Moon or Jupiter or someplace else, that won't necessarily be 9.8. It'll be some other number. But right now, let's say we're on the Earth. And so I want to know, how much does a 12 kilogram box weigh? Well, the mass is 12 kilograms. And we automatically know that G, as long as we're on the Earth, is 9.8. And so we can just multiply 12 times 9.8, and we get 117.6 newtons is the weight of that box. So what if we have to go the other direction? What if we know the weight and we want the mass? Well, it's still the same thing. It's still weight is equal to mass times gravity. Except this time we know the weight. We know that's 14. We don't know mass, but again, gravity is 9.8. So this time we're going to divide 14 divided by 9.8. And we get a mass of 1.4, let's call it 3 kilograms. So if you know weight, multiply by 9.8. If you want mass, divide by 9.8. Let's do a little bit more complicated problem. Let's look at this one. We got a 6 kilogram box being pushed to the right by a force of 35 newtons. There is a friction force of 9 newtons between the box and the table. What's the box's acceleration? For a lot of Newton's law problems, I prefer to actually draw out the situation. So I've already got it started with a box on our table. The box is 6 kilograms. It's being pulled or pushed. It doesn't make any difference because we're going to draw the arrow the same way either way. By a force of 35 newtons. We have friction. Friction is always the thief. It always takes away. So it's always going to go the opposite direction of your motion. Of 9 newtons. And we want to figure out the acceleration of the box. Well, here's the thing. If I draw the picture, I automatically see that I've got a force one way and a force the other direction. So that lets me know that I'll probably want to start off with this. F net equals the force in one direction minus any forces going the opposite direction. That's that sigma F equation, simplified down. So you always draw your main force first. So that's 35. Then friction is always the thief, 9. So F net is going to be 26 newtons. Well, that doesn't answer the question because we're looking for acceleration. So what we need to do is we need to do one more step. And so if we're looking for acceleration, we know the net force and we know the mass, so we can use this to find the acceleration. 26, mass is 6, and we got to find A. So 26 divided by 6 gives us 4 with 3 repeating. So we're going to round that off to 4.33 meters per second squared. And that would be the acceleration of that box. This is sort of like a mid-level question. A much harder one is where we have to do all 3 steps, where we have to deal with mass and weight and maybe some type of force holding it back, and then figure out acceleration or a force being applied. So let's take a look at one of those. On this one, we have a lifting problem. I've already sketched things out. We've got an 18 kilogram box. We've got an upward force of 601.5 newtons. But if you're lifting something, you have to overcome one very important thing, and that's its weight. If you can't lift with at least its weight, that box is not coming off the ground. Anything over that's great, but there is a minimum that you have to use. And we're still looking for the acceleration of this object. So one thing I can do is I can definitely start off by finding the weight of this object. And weight is mass times gravity. So the mass is 18, gravity is 9.8. And so if we figure that out, 18 times 9.8 gives us a weight of 176.4 newtons. So we have to at least lift with that much just to get it off the ground. Well, we're lifting with 601.5, so we got plenty of force. So it's definitely coming off the ground. So we need to figure out by how much, what's the net force that's actually moving the object. Because the first 176.4 newtons of this is just going to counteract its weight. What's left over is actually going to move it. So F net equals, this is that summation of the forces thing. But you can think about it as simply, in this case, force up minus the force down. And the force down would be the weight of the object. So we got a force up of 661.5, a force down of 176.4. So let's just subtract those. So 661.5 minus 176.4 gives us a net force of 485.1 newtons. Okay, so now we know the net force. We know a mass. We should be able to find an acceleration. All we have to do is apply Newton's second law to it. F net equals ma. F net is what we just found, 485.1. The mass is 18 kilograms, and we got to solve for A. So 485.1 divided by 18 gives me an acceleration of 26.95 meters per second squared. So that would be the upward acceleration of my object. All right. Thank you for tuning in for more physics content, and I will see you later. Goodbye.